we're going to look at functions and their graphs, and this is part 1 where we're focusing on vertex form. So first we're going to define standard form and look at getting the y-intercept from standard form, and then we're going to look at getting the vertex from standard form, and that will lead us into actually defining what vertex form is. Okay? The things you're looking to be able to do in this video is determine the coefficients a, b, and c from standard form. Use the equation x equals negative b over 2a to find the axis of symmetry. Use the axis of symmetry to find the vertex, and then be able to rewrite standard form as vertex form. All of those are connected, okay? So let's start with standard form. So in order to understand vertex form, we need to start with the basic form standard form, okay? So standard form of a line was that y equals mx plus b, which you might remember from previous math years. Okay? Standard form of a quadratic, though, is f of x equals ax squared plus bx plus c. Okay? And we call that a our leading coefficient. Right, we call it leading because it's with the x squared. And if I'm writing my quadratic in standard form of a polynomial, highest exponent to lowest exponent, it's going to come first. Okay? Then your bx is your linear term and c is your constant. But you need to make sure you know that this is your leading coefficient. Okay, so one of the easiest characteristics of a graph that you can find in standard form is the y-intercept. Right? We know how to find a y-intercept on a graph. It's where we touch or cross the y-axis. But we can actually find it really quickly from an equation. All you have to do is set your x equal to 0. If you have a y-axis, that means, or a y-intercept, that means you're on the y-axis, which means you haven't moved left or right any, so your x would have to be 0. So I'm going to put my x to 0 and see what I get. So in standard form here, x squared plus 4x plus 2, if I plug in 0 for x, I get y equals 0 squared plus 4 times 0 plus 2. Well, we can see that this first term is just 0. The second term is just 0. And then we're left with our last term there of 2. So my y-intercept would be 0, 2. And that's it. And I put the graph down here so you can compare. Okay? So we got 0, 2 from the equation by plugging in 0 for x. And you can look here. Our y-intercept is at 2. Okay? So when we're looking in standard form, when we see that c, we can actually say that is our y-intercept. Okay? If I plug in 0, this term's going to cancel, this term's going to cancel, you're left with just c, your y-intercept. So see if you can look at example 2 here and tell me what the y-intercept is. Okay, plug in 0 for your x. All right. Or use the shortcut that I just talked to you about. That is just your c value, -6. We would write the y-intercept as a coordinate point because we're talking about a point on a graph. Okay, and let's see if we can see that correlation here. And there it is. Y-intercept of this quadratic was at -6. Okay? All right, another characteristic you can find from standard form is your vertex, but it takes a little bit more work. But it's helpful to know how to find your vertex. That way, if you want to put standard form into vertex form, this is the process you would need to use. The first step is actually going to find the axis of symmetry. Remember, the axis of symmetry shares the same x value as your vertex. Okay? So first, we're going to find our axis of symmetry so that we have the x value of our vertex. And we use this formula. X equals -b over 2a. Make sure you make note of that formula. Okay? And when we're talking about a, b, and c, we were talking about the coefficients in standard form. Remember, it was ax squared plus bx plus c. So I'm going to look at my example here, and I'm going to find what a, b, and c are. A is always with x squared, so that would be 2. We're talking about the coefficient, the number being multiplied. B is always with x, so that would be 8. And c is your constant, and in this case is your -5. Be careful of your signs there. So let's take those numbers and plug them into our formula. x equals negative, and then our b over 2 times our a. So our b here was 8, and our a here was 2. So I plugged in my b, I plugged in my a, and now I'm going to simplify. So that gives me a negative 8 on top, and 2 times 2 would be 4. Negative 8 divided by 4 is negative 2. So we have our axis of symmetry. X equals negative 2. That's also the x value of the vertex. And if I have an x and want to find a y, you just plug your x in. So once I know what x is, I just got to plug it back into my equation. So that's going to be y equals 2, plug in my x squared, plus 8, plug in my x, minus 5. And in this case, my x was negative 2. We just found that from the first step. So now we just got to simplify, and you can use a calculator to simplify here. So if I do 2 times negative 2 squared plus 8 times negative 2 minus 5, I'll get negative 13. So y equals negative 13. Once you have an x and a y, you can write the vertex as a coordinate point. Remember, it should be a coordinate point because you're talking about a point on a graph. So our vertex is negative 2, negative 13. Okay, so that's how you would find a vertex from standard form. So let's practice a couple times. So the first step here is to find your axis of symmetry. X equals negative b over 2 times our a, but let's plug in our a and b. So our a here is the number with x squared, right? Well, the number being multiplied by x squared is an understood 1. B is the number with x, which is our negative 4, and c is our constant, which is 7. So if I want to plug in negative and then our b, notice I did negative then parentheses. Our b is negative 4, so I'm going to put in negative 4 in the parentheses. We have a double negative there, that's okay. And then 2 times our a, which is 1. What is a negative times negative 4? It's just a positive. Negative times negative is a positive. 2 times 1 is 2, and 4 divided by 2 is 2. So now we have our axis of symmetry, x equals 2. If we want to get our vertex, we need to plug that back in. Plug it in for x. So f of x, or y, equals, plug in our x squared minus 4 times plug in our x plus 7. In this case, our x was a 2, so I'm going to plug in the 2. And you can use your calculator or your brain here. 2 squared minus 4 times 2 plus 7. I'm going to use a calculator just so I don't make any mistakes. And that gives us 3. Okay? Now, remember your vertex should be a coordinate point. So our final answer is 2, 3. Okay? I'm going to give you a minute on example 3 to find your axis of symmetry. So plug in your B and your A and simplify. Okay, so our A should have been 3, our B 2, and our C is 4. Plug in our negative B over 2 times A would be a negative 2 divided by 2 times 3. And if we simplify that, we get negative 2 over 6. It's a fraction. We can simplify the fraction, negative 1/3, but it's not a whole number, and that's okay. Sometimes you'll get a fraction, you might get a decimal. I like to leave it as a fraction, but decimals are okay too. So we would just take that number and plug it in. Okay, it works the same way. Y equals 3, plug in your x squared, plus 2 times plug in your x, plus 4. And our x here was a negative 1/3. So I'm going to plug in a negative 1/3. And you could do this by hand or in your head. And again, I'm going to use a calculator for speed. So 3 times negative 1/3 squared plus 2 times negative 1/3 plus 4. And that would give me, in fraction form, 11 over 3, which is approximately 3.67. If you're wanting to graph it, you would want to know the decimal form. But if we're just writing our vertex, we would want to know the exact value because that's going to give us a more exact equation. Okay, so that's finding a vertex from standard form. Now, why is that handy? Well, if you can find the vertex from standard form, then you can write your equation in vertex form. And we'll learn in the next video why vertex form is so handy. Okay? Vertex form of a quadratic is f of x equals a times x minus h squared plus k. So a couple things I want you to see here. This a is the same as the a before. This is your leading coefficient. So when you learn what a can tell you about a graph, it's the same in every single form of the equation. A is A is A. Now your h and k are important here. And notice it's a minus h. H and k actually are your vertex. Your vertex is h, comma, k. So if you're in vertex form, you can find your vertex immediately. Just like if you're in standard form, you could find your y-intercept immediately. We could just look at the c value. In vertex form, we can just find h and k. Okay? And what that also means is if you know your a, you know your h, you know your k, you can write your equation in vertex form. So let's practice that. If we want to go from standard form to vertex form, first we find our vertex, and then we got to plug in our a, h, and k. Well, I'm going to use the ones that we already found the vertex for. So this example is the same as this first one up here. Right? And the second example is the same as our example 3 up there. So we already have our vertex here. Okay? We've just got to look for our a, and our a was 1. So let's write that out. So a was 1. And then our vertex was, we found it to be 2, 3. So what that means is our h was 2, our k was 3. Right? We have an a, h, and k. So now we just got to plug it into our formula. So we're going to say f of x is equal to a, which is 1, parentheses x minus h, which is 2, squared, plus k, which is 3. And there you go. You could clean it up a little bit. You could get rid of the 1 and just have x minus 2 squared plus 3. But now you have gone from standard form to vertex form. Okay? We just need to know our a, our h, and our k. So see if you can do the same thing for this example. Let's write down our a, h, and k. Oh, there it is right there. So there's our vertex. Here our a was 3. And then our vertex was negative 1/3 and 11 over 3. So take a minute and see if you can write vertex form for this example. Okay, let's see if you did it. So it's going to be y equals, or f of x, that's fine. A was 3, parentheses, x minus h. Notice h is a negative 1/3, so I put both negatives in there, squared, plus my k. Now I can clean this up a little bit because I don't want to leave this double negative. A negative times a negative is actually a positive. So that actually changes to an x, there we go, plus 1/3 squared. Because that negative is already existing in our equation, when you add in another negative, it actually changes to the opposite. Okay, so you'll see that here. Our vertex had a positive 2 as the x value, but when it's in the equation, we see it as minus 2. Our vertex here had a negative 1/3, but when we see in the equation, we see it as a positive 1/3, and that's because of this subtraction sign that already exists. Okay, it's making it the opposite. Okay? So the last thing we just want to kind of tie it all together is when you're in vertex form, this is how powerful it is, okay? I can look at vertex form and immediately tell you what the vertex is. I just need to know my h and my k. Here's my h, here's my k. Now the other thing you have to do is keep in mind that the minus was already there. So if I said x minus 2, my h is just the 2. The minus is already there. And if I see a plus, the minus is hidden. It's hidden behind a double negative. So when I saw this plus, that actually meant it was minus a negative. So I need to make sure I pull that negative with it. So it should always be the opposite. So if I look at this example, y equals 3 times x minus 4 squared plus 5, I can tell you right now that the vertex is 4, 5. All right? Just by looking at my h and my k. And we can verify that on the graph here. If I look at my graph, I see that my vertex is at 4, 5. Okay? So let's see if you can do the last example, if it will let me scroll. Did something. There it is. Okay, so take a minute and tell me what the vertex is of this last example. Okay, let's see if you're right. If I look at the graph here, I see that my vertex should have been at -3, -4. So when I look at my equation, remember that plus tells me to do the opposite. So that should have given me a vertex of -3, -4. Your h, which is the opposite, your k, which ends up being the same. And that is what vertex form is all about.